probability of A and B conditional. So given two events A and B B, there was a condition on B for A, we can actually write this probability as like this. We can say the probability of A conditioned on B, so using a vertical line there, is going to equal the probability of A intersection B divided by the probability of B. So this is where there's some kind of extra condition of an event B on A. But if the two events A and B are independent, so this is if they're independent, the probability of A conditioned on B is actually just equal to the probability of A. And if this was the case, you could sub in P of A into your formula here. So we just get P of A equaling P of the probability of A intersection B divided by the probability of B, and you'd get times both sides by the probability of B, and you get the probability of A intersection B just being the probability of A times the probability of B. And that's only if the events are independent, if the events A and B are independent. Okay, let's have a look at an example. So we have two events A and B that are independent. And the probability of A is 0.5, the probability of B is 0.2. Find the probability of A intersection B. Or we can just use our formula for two events, two probabilities that are independent from each other. So we get the probability of A intersection B just being the probability of A multiplied by the probability of B to give us 0.1 for our probability. Well, let's have a look at an example with a condition, so we can use our conditional probability rule. So we've got our formula, the probability of A conditioned on B is equal to the probability of A intersection B divided by the probability of B. And our question is, we've got 3 red balls and 2 blue balls, and we're going to select 2 with replacement, and what's the probability of getting 2 red balls if we snuck a peek and saw the first one was red? Okay, so in this case, so our condition in this case is that we saw the first one was red, so we've got some extra information here. So the probability of A is going to be that we're going to get 2 red balls. And our event B is going to be the probability that the first one is red, because that's our condition. Our condition is that we already saw that the first one is red, which means that the probability of A conditioned on B is going to be the probability, this is actually our A. This is actually the probability of our A intersection B. That's where everything is happening together. There's going to be the probability of getting the red divided by the probability of getting our first one as red. So the probability of getting 2 reds in a row, well, there's 3 reds in the bag out of a total of 5, and we put the ball back because it's with replacement, and then getting the next red is 3 out of 5, divided by the probability of the first one is red is 3 out of 5, and they're simply going to cancel out, and we get our probability being 3 out of 5.